All right, so we've got three equations, three unknowns, and just sort of background information, if you will, is to talk about some ideas. If you had an equation, let's say x plus y is equal to 1, and you had another equation, x minus y is equal to 3. When you have two different things that are unknown, you must have two unique equations to solve those two unknowns. And to do it, what you do here is you could either add these two equations or subtract these two equations in an attempt to eliminate the unknown variable. If you were to subtract these two equations, you'd end up with x minus x, which would eliminate the x's, and that's the reason why we're choosing to subtract. And you'd end up with 1y minus a negative y, which is 2y, and then you'd subtract 1 minus 3, which is negative 2, you'd get y is negative 1. And then what you could do is you could substitute that negative 1 into either original equation, and you would get a value for x. Okay, so this is one of the backbone ideas of this topic we're going to talk about. Another backbone idea or concept that I'd like to introduce to you, the first one is we're eliminating a variable to solve for another variable. The second backbone idea or concept would come from, let's say, the equation 2x plus 1 is 4. Let's even make it easier than that. Let's make it x plus 1 is 4. You could probably do that in your head and see that x would have to be 3 to add 1 and get 4. All right, x would be 3 here. But what I'd like to show you is you could multiply that same equation by any number you want. The answer is 3. You can use mental math for that. But if you take this equation and multiply by, I'm just off the top of my head, let's multiply by negative 5. You multiply by negative 5, you get negative 5x minus 5 is equal to negative 20. You would add 5 to get negative 5x is equal to negative 15, and then you'd get x is 3. All right, you get the same 3 that you would have gotten with the original problem. And it turns out that you could have multiplied this entire equation by whatever you wanted, negative 5, negative 10, 20, okay, anything you wanted, and you would have ended up with that same 3. So it did not matter what you multiply this initial equation by. You would always get 3. All right, so these are two backbone ideas, this idea of elimination and this idea of being able to multiply an equation by anything you want, just so long as you multiply every term by that constant, and you would end up with the exact same solution. We're going to use both those core ideas in the solving of this three systems of equations. So notice how there are three unknowns. Here you had two unknowns, x and y. You needed two equations, but when you have three unknowns, you require three equations. All right, so let's use these principles, these ideas, to solve for both x, y, and even z. All right, so what we're going to do here is we're going to try to solve this same problem in a number of different ways. All right, so what we're going to do is we want to eliminate the x's. For this particular problem, I'm going to eliminate the x's. All right, why am I choosing to eliminate the x's? Because here I see a 2, and here I see a 2. In the same way we subtracted, I saw an x here, an x here, I subtracted. I see a 2x here, a 2x here, I'm going to subtract. So I'm going to take equation 1 and subtract equation 3 to eliminate the x's. This will eliminate the x's. All right? Eliminate the x's. All right? So we get 2x plus 4y plus 5z is 5. And then here I get 2x plus 4y plus 4z is 2, and I'm just going to subtract because that will get rid of those x's for me. Over here I tried to show you it's legal to do that. All right, so now what you end up with is the 2 x's cancel here and here, and you get 5 minus 4, which is z, 5z minus 4z, which is z, and you get 5 minus 2, which is 3. 5 minus 2, which is 3. All right, so we've got, here we eliminated both x and y. What I would suggest we do now is eliminate x and y again using 2 other equations besides the 2 that we used initially. All right, so let's do that. Let's do that with maybe equations 2 and 3. All right, so what we're going to do is we're going to take 2, notice how that's a 1x and that's a 2x. So you're going to take 2 times equation 2, and then you're going to subtract equation 3. And what that's going to do is eliminate the x again. You're going to eliminate the x again. Eliminate the x again. All right. So we're taking 2 times this entire equation. 2 times this entire equation. All right. So if we do that, we get 2x plus 6y. I'm multiplying this by 2, 3y by 2, plus 6z, and that's equal to 4. Common mistake here is oftentimes students, they'll multiply this by 2, this by 2, this by 2, and they'll leave that alone. And that'll mess up your entire problem. So here we get 2x. I'm just bringing this equation 3 down. 2x plus 4y plus 4z is 2. And let's subtract. All right, let's subtract. And what you end up with is you end up subtracting x minus 2x minus 2x is 0. 6y minus 4y is 2y. We subtract 6z minus 4z, you get plus 2z. And then you subtract 4 minus 2, you get 2. All right, so now we've got an equation. 2y plus 2z is 2. But you'll notice that earlier in the problem, we calculated what z was. So we'll substitute that z here. We get 2y plus 2 times z, which we calculated to be 3 earlier, is equal to 2. You get 2y plus 6 is 2. 2y is equal to negative 4 after you subtract 6 on both sides. And then you're left with y is equal to a negative 2. Y is equal to negative 2. All right, so you got one more variable to calculate. We got y is equal to negative 2. Got z is 3. And now what we're going to do is we're going to take either initial equation. I think this one might be the easiest to work with. Numbers appear to be smaller. But it doesn't matter which equation you would use to solve for this final variable. Let's rewrite this x plus 3y plus 3z is 2. And we're going to substitute. We get x plus 3 times y. We've already calculated y earlier to be negative 2. So we get 3 times negative 2 plus 3 times z. Z is 3, and that's equal to 2. We're going to solve for this final variable. You get x minus 6 plus 9 is 2. We get x plus 3 is 2. And you're going to get x is negative 1 by subtracting 3 on both sides. All right, so final answer is negative 1, negative 2, 3. So it turns out that what you've done now is you have determined the value for x, y, and z, that if you were to substitute this x, y, and z of negative 1, negative 2, and 3, here, here, and here, you'd get 5. You substitute negative 1, negative 2, and 3 here, here, and here, and you'd get 2. And then you substitute negative 1, negative 2, and 3, you get 2. So you've solved what's called a 3 systems of equations problem using this elimination technique, which was rooted in this idea of being able to add or subtract 2 equations, and then, like I said earlier, you can multiply an entire equation by any constant that you want, all right? And you would, you're not really changing the equation, all right?